Welcome back to the Scotti-BYTE channel, and this is Scott. One of the things that I've always enjoyed using in my home lab are IP surveillance cameras, along with a network video recorder. And my cameras of choice all along have normally been Reolink cameras. And so I have a couple of the Unifi Protect cameras, and the two that I have, well, actually I have three. I have two G3 instant and one G4 instant. But up until now, I really didn't have any of their PoE cameras. So that being said, I'm going to discuss some things around what makes Unifi cameras a little bit different. And also, the discussion today is going to center around something called the Unifi Protect Application Programming Interface. So I recently replaced one of my Reolink RLC 520A cameras with a Unifi Protect G6 turret. And the RLC 520A is a 2K camera, and it actually provides some pretty darn good resolution. But the G6 line of Unifi cameras all have 4K video, and their performance is really fantastic. And I want to talk about some of the things that are different about them. So most PoE cameras are managed from a web page. And Unifi Protect cameras really aren't any different because they have a web page also, although that web page doesn't really allow you to do any management. And in fact, you can't use a Unifi camera without a Unifi Protect NVR type of system, which can be a variety of Unifi devices. But as a standalone device, a Unifi Protect camera cannot be used. So here's an example of going to my network program here and accessing my Protect application, going down to the system area, and then going over to advanced. They have this thing here called a recovery code. And you can actually go to the address of your Unifi Protect camera. You can use the username UBNT, and then you can use this recovery code as a password, and you can actually log into a Unifi Protect camera. Now, that being said, you would think that the Unifi Protect camera therefore has web page management. But Unifi Protect cameras are managed by the Unifi Protect application, and they are not managed by that aforementioned web page. So here's an example of that web page, and it basically provides you a capability to do basic configuration, such as the IP address, what information is displayed on the camera. It has overall network settings, and it will actually let you do a manual upgrade of the firmware. But this is not the usual interface, and in fact this interface is reserved really for cameras that are unadopted for the most part. So my discussion today really is around the idea of the Unifi Protect Application API. So most cameras, again, like my Reolink RLC 520A, are managed at the camera web interface. And Unifi Protect cameras are adopted just like other Unifi hardware devices, like their switches and their access points, or even their phones for unified talk. And cameras are no different. When you put them on your network, they're asked to be adopted by your Unifi system, and then you can access them from the Unifi Protect application. But independent of the Unifi Protect application, a Unifi camera really doesn't provide you any utility. So Unifi Protect cameras are really special in the sense that they send a raw IP stream to the Unifi Protect application wherever it happens to be running. I kind of refer to that as the Unifi Protect host, and that might be something like a UDM Pro, a UDM Pro SE, a UDM Pro Max, a Cloud Key Gen 2 Plus, or something like a UNVR, and those manage the camera configuration, the NVR function, and also these API calls that we're going to talk about as the primary subject of this presentation. So the Unifi Protect API, unfortunately, is rather largely undocumented. I did find a few GitHub pages that talked a little bit about the basics of it. The API for Unifi Network is discussed a little bit more often, but the API for the Unifi Protect for the video cameras is the one thing that I just don't find much documentation on, and that's what motivated me to turn that into a video. So I have this new Unifi Protect G6 camera, and one of the things that I notice, and this is kind of a personal pet peeve of mine, if you will, is that most PoE cameras today still have only fast Ethernet. That is, they have a 100 megabit connection. They do not have a gigabit connection on them. And so that being the case, they are limited somewhat in the speed and the bandwidth of the data that they can carry. So most 4K cameras that you're starting to see on the market increasingly are requiring H.265 compression, and H.265 compression basically has double the compression that the more common H.264 has. However, H.265 is not compatible with most browsers or streaming devices, which makes working with them somewhat problematic. And I've had a couple of videos in the past where I have demonstrated that and discussed that to some degree. So since the Unifi G6 cameras send a raw IP stream, or rather all Unifi cameras for that matter, send a raw IP stream back to the Unifi Protect host, and that's a UDM Pro. In my particular case, RTSP encoding, if that's what you want, is done at H.264, and it's done at that host, as are the other functionalities such as the API calls and things like screen snapshots. And having that H.264 stream for your 4K video allows for much broader compatibility. So simple screen snapshot grabs on a Reolink camera are actually pretty straightforward. You just have this little URL on a Reolink camera, and the same thing is true of an Amcrest camera and many other cameras on the market. It's basically HTTP, some IP address, and then there's some group of parameters following that, like a username and a password and that sort of thing, and it will go ahead and give you a very quick screen snapshot. And I'll show you a specific example later of what I use screen snapshots for and why I consider them to be important. But when I started using the new camera from Ubiquiti and started using the G6, my first question was, what? No snapshot URL? Surely you're mistaken. And so Unifi Protect cameras have no direct snapshot URL, and that's because the camera really doesn't provide any direct function from the camera itself. So the Unifi Protect API is used to request a camera snapshot. So likewise, the Unifi Protect server, in my case a UDM Pro, is also the thing that can generate and provide RTSP streams if needed. And you might point out the fact that Unifi Protect does have its own built-in network video recorder, and so sometimes you might want to provide an RTSP stream for other reasons. In my particular case here in my home lab, I like to be able to provide that RTSP stream to my Android devices that I use TinyCam Pro on. I like to provide that stream over to my Echo shows and my Fire TV 4K Max. So having an RTSP stream access is important, but the thing that generates that stream is not the camera again. It's going to be the UDM Pro, and it's coming from the Unifi Protect application itself. So this allows the camera CPU to basically be offloaded and reserved for important AI detections rather than streaming and API functions. So since we basically centralize all those and put them back on whatever the server is, that offloads the cameras. So this tutorial shows an example of how to access the largely undocumented Unifi Protect API, since I couldn't really find any information about it elsewhere. If you go out and you Google about the Unifi API, you're going to find some documentation regarding the Unifi API as it applies to their network controller program, but not really in terms of how it applies to the Unifi Protect camera system. So here's a really quick example of where I did a snapshot on my old Reolink RLC 520A camera, and I have a program that actually detects motion and takes a snapshot and stores it to a web server that I'll show you a little bit later on. And here we've got a little possum visiting the front porch and mooching off the cat food that I leave outside for the neighborhood cats that decide to visit us. And that actually looks like a pretty darn good picture. As I said, the Reolink RLC 520A is a 2K camera. It's a nighttime shot here, but I do have a porch light on, and I think that's a pretty great picture. Now, when we move forward here, the next screenshot is going to be for the Unifi G6 turret. And you see how much clearer that picture is because that's a 4K picture, but we're only displaying that here pretty much at 1080p because my video on YouTube is encoded as 1080p, but you can still see the detail. And here, if I hit the up arrow again and go back, the other thing that you notice about the Reolink camera is although it has a really wide angle view in both height and width, the Unifi G6 turret tops it by far. You can see that it is getting the entire door, and it's also getting most of the way down the sidewalk, whereas the Reolink RLC 520A is getting a little bit of the sidewalk, but only about 2/3 of the doorway and the majority of the porch, but the G6 turret is getting most everything. About 3 days ago, I replaced my Reolink RLC 520A camera with this Ubiquiti Unifi G6 turret, and I gotta say that I've really been pleased with it since. I wanted to show you a picture during the day, and if you notice the rose bushes in the top right of the side there, you can see that they're moving pretty freely, and this is simply a live capture from that particular camera. If we go over to my Unifi Protect application where you do manage these cameras, you'll notice that I have here my driveway camera is a Reolink camera, my front door is now the G6 turret, my front yard is a Reolink camera, and my mailbox camera is a Reolink camera. And then I have a sidewalk camera, which is a G4 Instant. And then I have two cameras called Thing 1 and Thing 2, which are in this office here, and they're both G3 Instant cameras. I have an application, or I should say really a device, running over on my Habitat, which is called Camera Motion Timelapse. And specifically, You can set this up for multiple cameras, but I have this set up for my front door camera, and specifically the way that it works is that I provide it a snapshot URL, and this used to be the snapshot URL for my Reolink camera. But since the Unifi G6 turret does not have a snapshot URL, I had to create one with a proxy server using the API, and that's what this video is about. So basically what this application does is it says, here's your camera image URL for a snapshot, and then here's how many images or frames I want to capture, and then the display delay between frames, in my case, is 1 second. And that's how this application setup looks for this thing. The camera motion time lapse itself has a main web page that is called the camera motion time lapse device. And under this device, if I look at preferences, it gives the URL of a web server. So this is the URL of a particular web server. And so that web server is the thing that captures the motion. And so now if I move over to the application itself, you can see across the top it has several different times. I don't know if you can see it, but across the bottom it has the frames 1, 2, 3, 4, 5, 6, 7, 8. And when it sees motion, it captures 8 successive frames, 1 second apart. So you can see that as I return, walking down the sidewalk, it detects my motion and I have several freeze frames. I can go back to any particular point in time. So for example, I'll go back to 10:22 last night, and there's a raccoon that decided to visit the front porch, and you can see the successive frames as he's sitting there eating the raccoon food, cat food, and that's basically how this application works. So you can understand why I wanted to reproduce the ability to do a snapshot from the Reolink or from the G6 turret camera, since it was supported with the Reolink but not from the G6. Something I mentioned just a few minutes ago in the slides is that we can go to the address of the camera. 192.168.30.25 is the address of that front porch camera that you saw, and I'm giving the username of UBNT and then the password that I found from the location of the Protect application from System, Advanced, and then this recovery code. So if I go back over here and say log in, it'll actually log into that camera and it will show me a live shot of that particular camera. Now this interface doesn't give you the ability to do much of anything. It just gives you the address. It'll let you click off some status information. You can go over to network and you can actually change whether it has a static or DHCP address. And you can do that, by the way, through the standard Protect application, as you would expect. And then finally, over in the system area, you can do manual firmware upgrades over here. And I suppose this is mainly a maintenance interface that you could use if you had not adopted a camera, or you had kind of a rogue camera that you were trying to gain control over. So I went ahead and dropped down to a command prompt on my desktop, but I want an environment so that I can simply do this demonstration. So I'm going to do an Incus launch, images, Ubuntu 2404, and I'll just call this Protect API, and it will use the default profile. And in this particular case, I'll go ahead and say the bridge profile, and boot.autostart equals to true, having a dedicated environment, and that's what an Incus container gives you. So I'll go ahead and do an Incus shell into Protect API. Let's do this, add user Scott, And let's go ahead and give Scott a password and verify that. And once we got that set up, let's go ahead and do a user mod -a G sudo Scott, putting Scott into the sudo group so we have privilege to do privileged kinds of things. Let's go ahead and do an SU over to the Scott account. I'll go ahead and clear my screen. And of course, our permanent working directory is going to be /home/Scott. First thing you want to do anytime you fire up a new system, and a new container is a new system, is we want to do a sudo apt update to make sure that we update all of the repositories from where it finds the updates to occur. And the thing that you can do is you can do a sudo apt upgrade afterwards, since it said it had one update to be taken, and it didn't take that one, which just basically tells me that it is a deferred update, and that's for OpenSSH client, and obviously it needs some other updates before that can actually occur. So we're going to have some dependencies today in order to do the work that we're going to work on. So those dependencies are going to be Python 3 and Python 3 pip and the Python 3 virtual environment. I like OpenSSH server so I can connect to my computer remotely, the nano editor, curl, and JQ, which is a JSON query program that I've covered in previous videos. So now we're installing all of those tools. I have several user accounts on my Unifi system, and you're going to want to create a local admin. So go over here to your Unifi Protect, or for that matter, even your Unifi network. Go down to the settings option, go over to admins and users, and click on create a new admin. I'm going to call my admin test, and then I'm going to say restrict that to local access only. And then once I do local access only, I guess it's going to ask me for the username again. So I'll go ahead and say test, and the password that I'm going to put in here will be just a little bit easier to remember. And I'm not going to set this up as a super admin. Don't use a predefined role, but instead go down here and turn off network management, but go ahead and for Unifi Protect, I'll go ahead and say full management. I don't probably need full management, but I'm not sure what I'm going to do in this demo. I'll go ahead and turn off the management for my phone system, Unifi Talk, and I'll turn that off also for the settings. So I'll go ahead and create this user account, and I now have a local user account by the name of test. So now in the background, all of our dependencies have completed their installation. And now that we have our local user account, I really shouldn't have said user account. Now that we have our local administrative account for Unifi Protect, we're ready to move forward. The way that the API for Unifi Protect operates is that first of all, we have to initiate a login request. And we do that with a curl command where I'm asking for the results of that authorization to be returned into this cookie file. Next, I'm addressing my UDM Pro at the address of my gateway on the UDM Pro, which of course is where my Unifi Protect application is running, which is 172.16.0.1. In your case, it's probably 192.168.1.1, and it accesses the API for authorization and login. And then it's going to return some JSON information, and the JSON that I'm providing it on the input side is literally the username test and the password ABC 123456789 ABC. And when I hit enter, it goes ahead and spews back a whole bunch of data. Now, the next step that I can do is, after grasping that authorization information, I can find out information about all of my cameras. And the way that I do that is with this curl command, where I use the cookies file that we just generated. Again, I point to my UDM Pro at 172.16.0.1, and this time I'm going to talk to a proxy program for the Protect application and the API, and I'm requesting information on the cameras, and I'm using the JSON query program we installed as one of our dependencies, and when I hit enter, it will list all of the Unifi Protect cameras added into my Unifi Protect system, which are Thing 2, Mailbox, Driveway, Front Yard, Front Door, Sidewalk, and Thing 1. So if I'm interested in my front door camera, which is the G6 turret, this ID number here is the ID number that I want to use in subsequent requests to the API to do things to the front door camera. Now that I have the ID of the front door camera, I can execute this command to the API, which basically uses the same cookies file, points to the same UDM Pro address where Unifi Protect is running, and I'm going to the API for the cameras, but specifically this camera ID, and I'm requesting a snapshot. The output of that snapshot is going to go into a file called snapshot.jpg, and you can see that it output a file that was 1.3 megabytes in size. And so if I do an ls-h human readable, and I guess I should have done -al-h or ALH, it will list out the cookies file, but it lists out the snapshot file, which is 1.3 megabytes in size, and that is a JPEG snapshot of that front door camera. Since as one of the dependencies we installed OpenSSH Server, and since OpenSSH Server supports secure file transfer protocol, I can use my Linux file manager, Nemo in my case, to bring up a file management window over to that container, which is at 172.16.1.205. I navigate down into the Scott folder, and there you see snapshot.jpg. If I double click that, it goes ahead and brings up the screen snapshot that we just got from the API. So obviously, rather than performing all of these manual steps, I wanted to be able to automate this process. So what I ended up doing was I went ahead and installed a Python virtual environment, which I called snapshot-env. And once it created that snapshot environment, I'm not real good on Python, but the first thing you need to do is jump inside that virtual environment, and we go ahead and do a source on that snapshot.env or -env and tell it to activate. You can see here that our prompts changed from just Scott at Protect API, but it now says we're inside of the snapshot-env Python environment. The next step I have here is I want to go ahead and do a pip3 install Flask request, and that is the command that basically builds our web framework in order to write applications in Python. Next, I'm going to go ahead and create a file to contain the script, and that file is going to be called the Unifi Snapshot Proxy Python file. So I go ahead and hit enter to enter the nano editor. Now I've pasted the contents into this file, and I want you to notice, first of all, there are a number of requirements for various libraries at the top of the file. And then we have a configuration section. Our username here is test. Of course, your username is going to be whatever username you chose in Unifi Protect. My password is ABC1234567890 ABC, and yours would differ too. And my camera ID for my front door camera is the one that you see here from that previous command we did. And my UDM Pro URL is this 172.16.0.1. Your URL may differ because it might be something like 192.168.1.1, which would generally be your gateway address on your Unifi network. And don't worry about the fact that this is called UDM _Pro URL. It's just what I happen to call it in the script name. So if you have a different device, this will work under that as well. So then I'll tell you at this point in time, what I discovered is that since I wanted to do rapid fire calls to get these snapshots, the problem I had was that Unifi Protect was too smart. And when I did subsequent snapshots every 1 second, it went ahead and cached the first snapshot and gave me that same snapshot every single time. And I went around and around in circles to kind of figure out how to solve that. The other problem I had is that periodically my cookie file would time out and I would need to get a new cookie file or initiate a new login. Still, other times when I tried to do a login every single time, then it went ahead and locked me out because of repetitive logins to the API. So then I enlisted the help of ChatGPT. ChatGPT and I had about a 30 to 40 hour discussion going back and forth, and ChatGPT accessing all resources on the internet and me asking exactly the right questions, and eventually we derived this script that was working correctly. So here you can see that it is performing the login, it's checking for the status and whether or not the token is valuable or valid for this particular login session, and it is taking the snapshot request and it is trying to find out whether that snapshot request worked or not. And then if not, it went back and did it again. And that's the contents of this file. So I'll go ahead and include this in the show notes because it is thoroughly tested. I'll do a Control-O and Enter to write the file out, and a Control-X to exit the Nano editor. So at this point in time, it's very important that we also change the permissions on our Python file to make it executable, and we do so with the chmod +X on Unifi snapshot Proxy.py. Since we're still in our Python virtual environment, I can go ahead and invoke the script by doing a Python Unifi snapshot Proxy.py. And that will go ahead and invoke the script, and it says this is a developmental server, do not use it in a production environment, and we'll get around to how to fix that just here in a little bit. In order to test our script, we simply go up to http://172.16.1.205, which is the address of the Incus container where we have the Python script running, and then port 5000. The reason I didn't use a lower numbered port like port 80 is because otherwise you have to do additional things from a permissions perspective. And then the name of the snapshot is simply /snapshot.jpg. When I hit enter, it will go ahead and invoke the API, and there it displays a real-time snapshot of the front door camera. So now I have a snapshot URL for a G6 turret camera, and this 172.16.1.205 is a proxy server that calls the API for the Unifi camera. Headed back down to my terminal session, the only particular problem with this application is that we can't log out because it's running real time in the terminal. Although it's interesting here because, as you notice, it says that it had a snapshot requested from that particular location and it actually ran. So that's part of the log. I do a Control-C to quit that, and we're back in the Python virtual environment, but the script is not running anymore, and so therefore the terminal is not running the application. So at this point, let's deactivate the virtual environment by doing a deactivate, and that will return us back to the Protect API prompt. So what do we do to get this program to run all the time? And the answer is we're going to go ahead and create a service. We're going to do a sudo nano /etc/systemd/system, and then we're calling the name of our service unifi-snapshot.service. And then we go ahead and enter the editor and paste in our service definition, which is really simple. It's simply called Unifi Snapshot Proxy, and it has to run after the network starts on the container, which makes perfect sense. And then I simply say execute the start as /home/scott/snapshot-env/bin/python, and then this Python script, and that ensures that it runs inside the Python virtual environment we created. The working directory is simply the home/Scott directory. Restart equals always make sure that the Python script is up and running in the event that it ever has an issue. It's running on behalf of user Scott, and it is running in production mode. And then I go ahead and do a Control-O and Enter to write the file out, and a Control-X to exit the Nano editor. Whenever you make a change to the systemd service, it's a good practice to do a sudo systemctl daemon reload, which goes ahead and reloads all of the services on the disk located in the systemd service directory. The next thing I want to do is I want to enable that service so that service starts on each and every reboot, and you can tell that it did that because it says that it has enabled that service by creating that symlink. And finally, if we wanted to actually run at this point in time currently, we need to go ahead and say sudo systemctl start on that, and we can see that that service is up and running by doing a systemctl status on that same service name, and there our service is up and running. Going back up to our web browser, now that this is running as a service, I'll go ahead and hit enter, and we get another snapshot, and I can hit enter and keep hitting enter, and I will keep getting a snapshot. If you're looking very carefully in the upper right hand corner here, you can see those rose bushes are changing position, which is showing you that our rapid fire snapshots are actually working correctly. So we now have a systemd service that is running on a proxy server, and that proxy server can do snapshots from a Ubiquiti Unifi Protect camera. So in virtue of having created the snapshot proxy server that I just demonstrated, I have a way from my Habitat application to point to a particular proxy server, and this was my production proxy server I have here at 192.168.30.151, since it is on my IoT network where my IoT devices such as my cameras reside, and then I gave it a frame capture count. And then if we look back over to the application itself, it points to the web server at 192.168.30.15. And as I demonstrated earlier on, that web server here is capturing 8 separate screenshots from 8 separate calls to the proxy server in order to do a screenshot from the G6 turret camera. And that's what you're seeing here in this application on this web server. And many times it's really nice to track motion events for something that operates as simply as this does. So in summary, Unifi Protect cameras offer more power and functionality than counterparts from companies like Reolink, Amcrest, and others. And Unifi Protect can now support third-party cameras as you work on transitioning to Unifi cameras in the future. And Unifi Protect cameras require a Unifi Protect host in order to function, like a UNVR, a UDM Pro, or even a CloudKey Gen 2 Plus. And the Unifi Protect API offloads the CPU-intensive functions from the camera to the Unifi Protect host, for example, the UDM Pro in my particular example. And this tutorial showed one simple use case on how I used the Unifi Protect API to store time-lapse screenshots. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.